Okay, everyone. So you should have your headphones in. You should be taking notes while you listen. So your objective today is that you can create a scatter plot. We're just going to do this with a sketch. We're not actually going to scale out scatter plots. Determine which function or line is the best fit for a set of data and use the line or best fit to answer the question. So your two main focuses are that we're going to create a line and we're going to use the line or the equation to answer some questions. Alright, so let's kind of talk about what a scatter plot looks like. So in each of these four examples, you guys have a scatter plot. A scatter plot is just a set of data points on a graph. It won't follow an exact line, but it's scattered in a way that might look like a line. We're going to focus on either a scatter plot that looks linear or a scatter plot that looks exponential. So if you could take your pencil and just kind of draw a line that is a best fit is going to go through your data points. Make sure you're not connecting the points, otherwise it's not linear, it's got to be a straight line, as best you can. So something like this where it kind of goes through the data, not above or below. A bad line would be something that looks like this. It needs to follow your data. A bad line would be something that looks like this where it's above your data. Okay, it needs to follow the data as much as possible. Right? This one down here you can see looks exponential. If you follow the data, it should look something like this. And then this one over here, pretty scattered, but you can see it still looks linear. So something like that. Make sure you throw arrows on the end of your line. Okay? Alright, so example 1. It says Andrew wants to estimate his gas mileage or miles per gallon of gas being used. He records the number of gallons of gas he purchased and the total miles he traveled with that gas. Create a scatter plot showing the relationship between gallons of gas and miles driven. So here's your gallons, that's your x-axis. Here's your miles, here's your y-axis. So we're going to label the x-axis as number of gallons. This is the only time we're actually going to plot points like this. Every other time we're just going to make a sketch. And then your y-axis is your number of miles. So if you take a look at the data, it's saying that on 15 gallons he went 313 miles, on 17 gallons he went 340 miles. So if you know anything about cars, your gas miles is definitely not consistent. It's close each time, but it depends on if you're driving on the highway, on the road, how much you stop and go, that type of thing. Okay, so why don't you guys plot those points? I'm going to pause it and plot those. So go ahead, pause it, plot those points, and you can unpause it. Okay, so your data point should look something like this. It's just an estimate, so don't worry if they're not really close. But it should look all clumped together like this. Okay, so then if you look down below, it says which equation is a better estimate for the data? Y equals 10x and y equals 22x. Show your work. How is the equation related? All right, so let's say that we think that the line y equals 10x is correct. We're going to take our calculator. And actually, let's make sure that we reset our calculator so that it's all in the same place. So go ahead and hit second plus 712, and we'll clear our calculator. Go to y equals, and we're going to type in 10x. Okay, so there's our equation. Alright, so then what I'm going to do is I'm going to look at my table of values, and I'm going to plot some of these points. So I'm going to start at 0, 0. Okay, so I'm going to plot a couple of these points, but I'm not going to plot all of them. I'm going to go over to 880, plot that point, so go back here. Let's go over a little bit more, let's go maybe 16. Easy 16's at 160, so there's 175, somewhere about here. So you can see from this that your line is going to look like this, not even close to the data, so we know that that one's not a good one, and we're just going to make sure that 22x is a good one. So I'm going to go back and I'm going to change this to 22x, go to my table of values, I'm going to plot a couple of these points. So that one's also going to start at 0, 0, and then at 8, it's at 176, so all the way up here, just color. And then at 16, it's at 352, right about here, so you can see that this is actually following, if you can draw a straight line, is actually following the data. So this equation right here is the best line fit. Okay? And then, So it says, how is the equation related to the gas mileage? So the equation y equals 22x just means that this car is getting about 22 miles, oops, sorry, 22, yeah, 22 miles per gallon. So every gallon of gas, they get 22 miles. Okay, so flip over to the next page. All right, the next page, you're given 3 graphs and you're just asked which equation is a better fit for the data. So we're going to do the same thing, and we're just what we just did, and we're going to put both of these equations into our graph, and we're going to kind of see which one follows our data better. So that's what we're looking for. So go ahead and pick up your calculator. We're going to go to y equals, and we're going to put in those equations. So we're going to put 9x plus 30, and then we're also going to do 12x plus 25. So I'll go to my table of values. So I'm going to plot the first equation. I'm going to plot, so I know that I'm going to start at 30 right here. So 0, 30 puts me here. And then I'm going to space them out a little bit, and I'm going to go 4, 66. I'm going to go 8, 102. And that puts me, that's weird. And then that puts me right there. So that one follows the data pretty well. That's probably our equation, but we'll check. We need to check the other one as well. So the other one we know is going to start at 0, 25, since that's the y-intercept. So it's starting a little below the other one. At 4, it's at 73. And then at 8, it's at 121. So you can see that this does not follow the data. It does go through the data, but through the data is not what we want. We want it to follow the data. So that means that that first equation is a better fit for the line, or a better fit for the data, and we're going to say follows the data. Follows the data better. So out of the two equations, that one's a better representation of the data. Okay, let's try it again. So now we get something that looks exponential. So we'll go back to our equation. Now we're going to change them. We're going to do 3.5 to the x. Make sure you raise it to the x. And then we're going to do 3 to the x. Now back to our table of values. Alright, we're not really going to see anything happen until we kind of get off of 1, 2, 3. So I'm going to start with 5. Well, actually, I'll start with 3. So, God, those are close. Let's start with 4. So 4 is at 150. So if that's 250, 150 is somewhere down here. And then the next one at 5 is at 525. So that's all the way up here. And then at 6, we're at 1800. So that's about up here. So you can see that this one's going to follow something that looks like this. So it doesn't really follow the data that well, so hopefully the other one will follow closer. So the other one at 4 is at 81, so we know it's below. And then at 5, we're at 243. So it's somewhere about there. At 6, we're at 729, so about there. So you can see that this one's actually going to follow our data better, which means this is our better. And we're going to say follows the data better. So that's our better equation. So even though they look like very similar equations, 3 to the x is definitely a better fit for the data. Okay. And then why don't you see if you can do the next one? Plug in both equations in your calculator, see what you get for your 2 lines. I'm going to go through it right now, and then you can unpause it. So go ahead and pause it right now. Okay, so this is what I got. So this was the purple line, and then this was the red line. So out of the two, the red line kind of cut through right in the beginning, but then stopped following the data, whereas the purple line followed the data for went right between. So we're going to say that this is the better equation, and because it follows the data better. So that's the only explanation that you need to give. The only reason we would ever choose one line over another is just because it follows the data better. Okay? Alright, so flip over to the next side. Alright, so now we're actually going to get into using our calculator to do this. So it's kind of a pain when we have to do it, but our calculator can do it for us. So this problem says that the principal at Park High School records the total number of students each year. The table below shows the number of students each year for the last 8 years. So in year 1 there were 630 students, at year 2 655. So you can see that as time goes on, that this number of students is increasing. The question is it increasing at a linear rate or an exponential rate? So here's what we're going to do. We're going to take our calculators. We're going to clear out everything that's in it. So second plus 712, we're going to get used to doing that. We're going to go enter this data in. So go ahead and hit stat, edit, so stat, enter. And in list 1, now we actually are going to enter in both list 1 and list 2, because in order to make a scatter plot, you need an x and a y-axis. So your x-axis will be list 1 and your y-axis will be list 2. So go ahead and enter in 1 through, go ahead and enter years in list 1 and this in list 2, and I'm going to pause it. Okay, make sure that you check your data, otherwise if one number is off, the whole thing is going to be wrong. Okay, so here's what we're going to do, and this is what we haven't done yet. So here's your data. What we're going to do is we're going to create a scatter plot. In order to do that, you're going to hit second, y equals, you notice above that it says stat plot. You're going to get this table, so go ahead and enter. Right now it's flashing, so we want to turn it to on. And now what we want to do is we can fit our window specifically to it. If I hit graph, I'm going to get this and there's nothing there. So what I want to do is I want to hit zoom. And if you notice, when you go down to 9, it says zoom stat. So that means it fits to your statistics that we just put in. So you want to go ahead and hit enter. And then you can see it fits it for you. So our sketch is just going to be very, just what does it look like? We're not going to scale anything out. We're just going to say that our x-axis represents our year, and our y-axis represents our number of students. And again, we're not going to sketch anything out. We're just going to kind of show that it looks like it's going like that. So kind of linear, kind of exponential, could be one or the other. Okay. And then part A says which function is a better fit for the data, y equals. So we have two equations, and if you notice, they're both exponential. So what we're going to do then is we're going to take and we're going to do y equals, and we're actually going to put both of those into our equation, so into our calculator. So 1.05 to the x, and then we're going to enter in the other equation as well. So 550 times 1.07 to the x, and then we're going to go ahead and hit graph, and we're going to see those lines follow. So that's the first equation. Looks like it's following the line, following the data pretty closely. Not so much right there. And then that one. So it's kind of close. The second one kind of just goes through the data. Like if I take out the first equation, actually, just from looking at this, the second one just kind of went through the data, so that one's not a good fit. So not that the first one's a great fit, but we're going to take it. So that's the equation that we're going to take, and we're going to say it's a better fit. And then it says, at this rate, how many students would you expect to attend the high school in 9 years? Well, if we know that our equation is right there at 589, and we're talking about 9 years, if we look at our table value, years is talking about your x, and number of students is talking about your y. So 9 years, we're just going to evaluate. So go ahead and write down y equals 589 times 1.05, and instead of to the x power, we're going to say to the 9th power. Okay. And then I'm just going to put that in my calculator. So 589 times 1.05 to the x, so to the 9th. So we're going to say about, talking about students here, so we can't have a decimal, so about 914 students. So by finding a function that fits our data, it allows us to make a prediction like this. Because our table only went up to 8 years, but now I can predict what might happen in 9 years, 10 years, 11 years at this rate. Okay, so let's try it again. So it says that the weights of oranges vary. Maria wants to come up with a way to estimate the number of oranges given a weight. She weighs oranges and records the weights in the table below. So this is your list 1 or your x values. This is your list 2 or your y values. So she's just saying that she has this many oranges, and then based off of that, this is how much it weighs. So she's trying to get a generalization that, like, if she's got 20 oranges, how much does she think that they're going to weigh? Something like that. Okay, so go ahead and first clear out your calculator so we can start from the scratch. So second plus 712, and then go ahead and stat edit, and then enter that data into your list 1 and list 2. And I'm going to pause it while you do that. So go ahead and pause it. Okay, so here's the table of values that you guys should have gotten. Let's look at our scatter plot. So go ahead and hit second y equals. Notice again that's off because we reset our calculator. We're going to hit enter and we're going to turn it on. And again, if we hit zoom and we go to number 9, that'll hit our that'll fit our window perfectly. So our sketch. So here's my x and y axis. I'm just going to label them according to what's on the table. So this would be number of oranges, and this is the weight in pounds. Okay, and then I'm just going to go off of what the graph is. So I'm just going to kind of estimate that it looks like this. And that's good enough. Okay, so I get two functions that I'm asked for which one is a better fit. I get this function or this function. So I'm going to go in my calculator, I'm going to go to y equals, and I'm going to type in both of those. So 0.6x minus 0.5, and then I also have 0.4x plus 0.5. So I can see I'm starting in two different places. I go ahead and hit graph. That's my first equation. It looks like a really good fit. That one does not look so good. So this one is definitely a better fit. Alright, so that means if that's a better fit and follows my data, that's the equation that I'm going to use to estimate and predict values. Okay, so if there were 20 oranges in a bag, how much would you expect the bag to weigh? So 20 oranges, if we look at our table of values, I can't scroll up. Oranges is talking about our x values right here. So that means that 20 is my x value. So I'm going to take my equation and I'm going to substitute in for x. So y equals 0.6 times 20 minus 0.5. And again, notice that I'm using this equation right here since that's the one that I've determined to be a better fit, which means it's a better predictor. Okay, so now I'm just going to use my calculator. I'm going to type in 0.6 times 20 minus 0.5, and I get 11.5. So y equals 11.5, and it says how much would you expect the bag to weigh, and that was talking about pounds. So about 11.5 pounds. Okay. The next part says that Maria has a bag of oranges that weighs 2 pounds. Approximately how many oranges are in the bag? Well, if this case we're talking about 2 pounds, and we look up at my table of values, my pounds is my y value. Oh gosh, sorry, this thing does not want to scroll. So right here, weight in pounds is your y value, so that means that my y is 2. So when I look at this equation right here, I'm actually going to say that 2 equals 0.6x minus 0.5. So in part B, we were substituting in for x. In part C, we're substituting in for y. In part B was easier because I just was evaluating, whereas in part C, I need to solve for x. Okay, so two different situations. One was an x value, one was a y value. So make sure you pay attention to where that value goes. Okay, I'm going to add 0.5 to both sides. Alright, so we have 2.5 equals 0.6x, so we're going to divide both sides by 0.6. Tell us that x equals we're going to say that x is about 4.17. Whereas for about how many oranges, so that obviously doesn't make sense, so we're going to say that our answer is about 4 oranges. Okay? Let's flip the page. Alright, so number 7 says word of mouth can be a great way to increase a movie's popularity. A small local movie theater released a movie. On the first day, only 5 people saw the movie. They all loved the movie so much that they told a few of their friends. The second day, more people attended and they told their friends. The pattern continued. The attendance for the movie is shown in the table below. Create a sketch of a scatter plot to show the data. So we know that our scatter plot's going to have an x and a y axis. Our x-axis is your days, and your y is your number of viewers. Alright, so go ahead and pause it and then enter this data into your list 1 for X and your list 2 for Y. And then make sure too that you reset your calculator. So second plus 712. Okay? Go ahead and enter your data in.
Well,
okay, so here's what you guys should have in your table of values. So just check to make sure they're the same thing. Again, we're going to go to second y equals. We're going to turn this plot on, and then we're going to hit zoom. And you can scroll down to 9, or you can just hit number 9. Okay, so here's what you get. So we're just going to draw a little bit of a sketch. You should be looking at this thinking that it's definitely going to be exponential. Okay. Okay. So it says 2 theater employees each try to determine a function to fit the data. One thinks that the equation y equals 5 to the x is a good fit for the data, while the other thinks the equation y equals 200x minus 200 is a good fit for the data. Which function is the most appropriate fit for the data? Alright, so based off of what it looks like, we should be thinking that it's got to be exponential, but we'll check both of them. We should check to make sure. Alright, so we're going to enter in 5 to the x. And then in the other one, we're going to do 200x minus 200. We're going to hit graph. So you can see that exponential function does follow my data really well, whereas that one definitely doesn't. It cuts through the data, but it doesn't follow the data. So definitely not a good linear function, so I'm going to cross that off. Okay, go ahead and look down. So which function is the most appropriate fit for the data? We're going to say y equals 5 to the x, and we're going to say it follows the data better. Okay, so by now you should be seeing that you enter the data into your calculator, look at your scatter plot, and then type in both equations so you can see which one follows the data better. And then we're using these equations to answer follow-up questions, because if you look at our table of values only tells us day 1, day 2, day 3, day 4. We're seeing that there's a pattern, and what we're saying is that if we can see that pattern, we can say, well, what's going to happen in 6 days, in 8 days, in 10 days, because our table only goes to 4. Okay, so those are the questions that we're looking to answer. So if this trend continues, how many people would you expect to see the movie on the 5th day? Well, the equation is y equals 5 to the x. And if it's talking about the 5th day, if we look back up here or at our graph, our days are talking about our x-axis. So that means that 5 is our x value. So we'll just have y equals 5. Oops. Y equals 5 to the 5th power. Okay, so 5 to the 5th, 3125. So y equals 3125. So that's about 3,125 people. So it's not an exact answer. Based off of this trend, we can expect 3,125 people to attend. Okay. If this trend continues, how many people would you expect to see the movie on the 10th day? Well, again, days is our x value. So now we're going to say y equals 5 to the 10th power. It's going to be a big number. Get that. So we get, I'm going to use the word about because the function is an estimate, which means that even though this is a whole number, it's still an estimation. So it looks like we have about 9,765,625. Make sure you put people with it so we know what we're talking about. It's a lot of people. Okay. Let's say, sorry, thought I fixed this in yours. This is supposed to be 80,000. It might be right in yours. If the town has 80,000 people, how long would you expect it to take until the movie is seen by everyone? Well, 80,000, now we're talking about people, is our y value. So again, here's your function. X is talking about our days, y is talking about our people, so that means that y is 80,000, which is equal to 5 to the x power. Now, make a note here, this is exponential. Your variable is your exponent. You guys do not know how to solve an exponent. Do not know how to solve. Solving exponentials is more of a math 3. So linear I can solve, but exponential unfortunately I cannot. So here's what I'm going to do. I'm going to look in calculator, so go ahead and write that down. And then, so I'm going to look at my y equals. I don't need this linear function since it doesn't make sense, so go ahead and delete that one out. And then go to your table of values, so second graph. And I'm going to look at my table of values for when my y is about 80,000. So I can see right here it's 15, and then right at 7 it's 78,000, and then it jumps up from there to 390,000. So that's 390,000 is obviously way off. That's a little bit less, but it's for sure closer than 8. So what I'm going to say then is about 7 days. Okay, 6 days doesn't make sense because it's only 15,000. 8 days doesn't make sense because it's 390,000. So about 7 days. Okay, so exponential is the only time that you're going to have to look at your table of values. Otherwise, you're just substituting and solving. Okay, so your homework tonight. Oh, I'm sorry, and I'm going to pass this out as well. This is a formula sheet. As long as you do not write on it, I'll let you guys use it on the day of the test. But if you need to write on it, go ahead, and I'll just print off another one on the day of the test. So feel free to write on if you want. You just won't be able to use a written on copy for the test. But this just walks you through how to create a scatter plot. So enter the data into list 1 and list 2, which is what you did. Turn the stat plot on, which is when you hit second stat plot and turn it on, and then to graph it, you hit zoom on. So this just walks you through what we did today. Okay? So your homework tonight is worksheet number 7. It looks like this. You're going to go through in number 1, 2, and 3, and you're just going to say which equation best fits. So that means that in each of these equations, you need to plot the line to see where the line follows. One of the lines might follow like this, whereas the other one actually follows the data. Okay, so that means just plot a couple points so that you can get a general idea of what your equation looks like. Okay, and then on the second page, you're going to actually answer the questions that we did. So you're going to say, you're given this data, create a scatter plot, and then which function is a better fit, and then you're going to go ahead and use whichever function you choose to answer a couple questions. So you'll do that in number 4, and then you'll do it again in number 5. Okay, the whole point of this lesson is so that you guys can create a function that fits the data and then use it to answer other questions. Okay? Alright, so now you can show that your notes are done and get your homework. Sorry that the video was all over the place. I got interrupted like 15 times. Alright, if you have any questions, come in tomorrow morning. Otherwise, I will see you tomorrow. Alright, thank you.